Let's begin with our sample demonstration of a single replacement reaction. I have a silver nitrate in the dropper bottle. That's 0.1 molar, so a dilute solution. And here I have a piece of zinc metal. This is zinc metal. And before you do a single displacement or replacement reaction, you need to sand the metal a little bit, because all metals will become oxidized in air. And in many cases, that oxidation will just lay right on their surface. So I'm using a piece of sandpaper and I'm just sanding the surface of the metal to expose the unoxidized metal beneath it. You can see that the unoxidized metal is shiny and the oxide is dull. Now, it's not important to take off every little bit of the surface oxide, but you do have to expose enough that the reaction can occur. These kinds of reactions take place on the surface of a solid. You know, when we did double displacement reactions, we combined two solutions together and everything happened in the solution. But in this kind of reaction where you have a solid reacting with the solution, the reaction is going to happen on the surface of the solid. So I've exposed enough of this, I think, for this to work just fine. And because this is the example, I think you've already, if you've read the lab, I hope, you've already learned that this is going to produce a reaction. So I'm going to put some drops here. And I want to put enough of the solution on the metal that we can actually have it fall off the sides. And this will let us see the edges. So right away, there is a change visible. The surface is getting much darker. And then again, I think it's easiest to understand what's happening when you look right at the edge. So we will wait a few minutes. And then for fun, let's really zoom in close on this. Because one thing that's so beautiful about metallic crystals is they often display a dendritic growth pattern. They branch out like trees. They almost look alive. So let's wait for a minute and watch this beautiful display. Let's look around some other parts of this. Just to give you some more views. Let's see if I can't focus here a little bit. There. Okay, our first demonstration. We're going to take zinc, metal, and we're going to add copper sulfate. Note the color of the solution, copper sulfate. Copper ions give a blue color to a solution. So we'll add enough that the solution spills over the edges of the piece of metal so that we can watch what happens at those edges, because that's where it's usually the easiest to see what's going on. All right. Let me show you that formula again. Copper sulfate. That's copper 2 sulfate. Roman numeral 2 indicates the copper is 2+. Okay, spread that around a little bit. Let you watch it for a few moments and then we'll switch to the microscope. And then I'll move this around. In this case, it looks like the precipitate sticks pretty strongly to the metal. So this concludes demonstration 1. Okay, demonstration number 2. This time we're going to use lead metal. And because of lead's toxicity, notice I've put on some gloves before I sand it. This is a piece of lead and I'm sanding it off. And the lead dust I'm going to clean up right away because that would be potentially dangerous if it were to get into anything. So I scratched the surface of the lead and I put it in the dish. Now I'm reaching for a cleaning wipe. And first thing I'm going to do is wipe off the lid of the cleaning wipes since I just touched them with my gloved hands. And that's the thing about gloves, is gloves are contaminated surfaces. So you have to be aware that this lead could spread. So then what I'm going to do is I'm going to take the cleaning wipe off my gloves with it, wrap it around the piece of sandpaper, and toss that. Okay, so now I have a nice piece of lead ready to test. And I'm going to test it with 2 molar hydrochloric acid. So remember that when the cation is hydrogen ion, H+, we're looking for evidence of a reaction, not as a precipitate, but when the hydrogen ion reduces, it gains electrons. Remember, reduction is gaining. And this will cause the hydrogen to become neutral. It'll bond with another hydrogen and make H2 hydrogen gas. So let's see if we can see evidence of that happening. All right, now let's move this over to the microscope. Well, we can certainly see the scratches we made. Okay, this concludes demonstration 2. All right, demonstration number 3. This time we have zinc metal back again, but we're going to put lead nitrate on the zinc metal. This is 0.1 molar lead nitrate. That's lead 2 nitrate. Leave that for a minute, let you watch it. And then let's take a look at it under the microscope. And this concludes demonstration number 3. Demonstration number 4. Here we have copper, and we're going to react it with silver nitrate, silver 1 nitrate. So let's do a little bit of exposing of the surface. The freshly scratched metal down, and let's add our silver nitrate. Whenever you spill, you have to clean up right away. Spills don't just sit, they move. So let me fix that. I was trying to add more without using the dropper, and that didn't work because this surface isn't quite level, but I still want to add a little bit more, just so that there's plenty of it there. Okay, I'm satisfied now. Now, do some of this. So again, that was silver 1 nitrate and copper metal. I always recognize copper metal because it's got such a distinctive color. Let's move this over to the microscope. And worth looking closely at, I think. This is a really nice view here. Okay, this concludes demonstration number 4. This is a piece of magnesium metal, and I'm going to be adding the 2 molar hydrochloric acid to this metal. And we will look at that under the microscope. Put another drop on while it's under the microscope so you can watch. So this is magnesium metal and 2 molar hydrochloric acid. Okay, this completes demo 5. This is demonstration number 6. Magnesium and zinc chloride. Zinc chloride. Magnesium and zinc chloride. Okay, let's look under the microscope. I want to warn you about something. Sometimes you think nothing's happening, and then you realize that you need to be more patient, that some reactions are much slower than others. Now, this is the same piece of magnesium that I used in the last demonstration. So I'm afraid there's probably still some hydrochloric acid having an impact on this demo. So please don't focus on the bubbles. I think that's an artifact of what was happening with the acid. Instead, I'd like you to concentrate on the precipitate, what's happening with the zinc nitrate and the magnesium. Okay. There we go. Kind of like that view. Here, some more. I think this is a really good way to convince you that these are in fact surface reactions. They're not just happening out there in the solution, they're happening very much on the surface of the metal. So this concludes demonstration 6. Okay, in this example, we are going to react copper metal with lead nitrate. Lead nitrate. Here we go. Copper metal, lead nitrate. Okay, we'll watch it for a little bit and then we'll check under the microscope. Okay, moving to the microscope. And this concludes demonstration number 7. That was copper and lead to nitrate. Okay, this is demonstration number 8. We're going to react the magnesium metal with the lead nitrate, the lead to nitrate. And let's move to the microscope. See how close we can get. This concludes demonstration number 8.